How to do integration by substitution? Well, most of the time you can integrate right away, but sometimes you can't integrate straight away and you have to do a little bit of rearrangement, or as we say, substitution. Sometimes it's called U substitution because we substitute U, which just happens to be a letter that we're using. The formula that you usually see with U substitution is the one I've shown you over here, and you probably don't understand it at all. I just want you to have a look at this particular area over here where I'm highlighting this part of it. I need you to see that this is what we call a composite function. It's a function within a function. The gx is a function that is within the f function. And this is when we have problems of integrating directly and we need to do U substitution. So in the first place, you need to identify the composite function. Let me give you an example. You should see that there are actually two functions in here. This is one function and this is another function. But the yellow one underlined yellow is a composite function. And this is because what's inside the brackets in here is a function within that power function. So here we would substitute U to be x cubed plus 6. Now, it's pretty tricky trying to find a function which we will designate to be U. I'll show you some of the possibilities. And as we said, U could be found in a power function, or U could be found in an exponential function. Also, U could be found in a root function. U could be found in a reciprocal function. U could be found in a reciprocal root function. And also, U could be found in trigonometric functions, such as, for instance, sine, and we might have a function in here. I have not exhausted all the possibilities, but I'm just here to show you the possibilities. So let's continue integrating our original function, the integral of 3x squared, and we had x cubed plus 6 to the power of 5 dx. Now we had an understanding that U is now going to be represented by x cubed plus 6. And we need to differentiate that U. So we'll differentiate the U, because if we differentiate the U, we are differentiating it with respect to x. So we have to say dx is equal to, and we just differentiate this, so this becomes x squared with the 3 in front of it. Now when we look at this, we can see that what we have is, let's just do this, 3x squared is actually our du dx. So that's really good. That means that we could substitute du dx with, we've got 3x squared, but we also have a dx over here, and that dx is also here. If I rearrange this particular equation so that I will have just du, it'll mean that du is equal to 3x squared dx. So now we can substitute the whole of 3x dx into 3x squared dx. So it'll look like this. The integral of x cubed plus 6 to the power of 5, and we substituted du for all the blue 3x squared dx. Everything that was highlighted in here in blue. All right, we can't integrate yet because we can't integrate du with x values. So we need to change it into a u. Okay, I remember we changed u to be x cubed plus 6. So let's rewrite this again and say that this is really u to the power of 5 du. Now you can certainly integrate that. So integrating that means that we increase the exponent by up to 6. So it'll be u to the power of 6 over 6. And because this is not a definite integral, it's an indefinite integral, we need to add a constant of integration in here. And now finally we'll just substitute the u back where we were, so that is x cubed plus 6 to the power of 6 over 6 and add on the constant c to it. Now I want to do one more problem with you. Okay, so we've got a problem here. We've got x plus 1 to the power of 3. And in reality, we could multiply it or expand this whole thing into one big polynomial. But we can also do it by integration by substitution. This is a composite function, and therefore the u can be made to be x plus 1. Okay, so the next step is that we differentiate u and we do du over dx is equal to 1. Now we'll move the dx to the right hand side. So du is equal to 1 dx. Now I would like to also show you that in the original we can make this 1 dx. So we can quite easily now substitute 1 dx in here with a du. And so we will have x plus 1 to the power of 3, and we can substitute 1 dx with du. Okay, so we can't integrate this because we're integrating it with respect to u, so we must change this to u. So we know that x plus 1 is u, so we will write u to the power of 3 du. And now it's easy to integrate. We raise it up into u to the 4, divided by 4, and add the integration constant. Finish it off by returning the values for u. So we have x plus 1, that's what we made u, to the power of 4 over 4 plus c. And that's our answer. So I feel that one more example would be of benefit to you. I'm going to show you one where we've got a 5x plus 2 and we're to the power of 7 dx. Now, if we wanted to, we know now that we can find what u is. U is going to be 5x plus 2. And we will now integrate this. Du dx is now equal to 5. Unfortunately, we don't have a 5 in here. What we would like to see is this. So now we would be able to substitute du is equal to 5 dx. But because we have a 5, what we're going to do is we can change that into a 5, that's fine, but we're going to need to divide it by 5 as well. Now that's going to cancel out, so that'll be all fine. So now we start again, and we've got 1 over 5 with the integral of 5x plus 2 to the power of 7, and we exchange it 5 dx by du. Now we know that 5x plus 2 is in reality a u, so we will rewrite this again, and we'll say that's u to the power of 7 du. That's easy enough to integrate, so we still have 1 over 5, and now we will integrate u7, so that will be u to the power of 8 over 8 plus c. Now all we need to do is just to simplify it and put the u back. So that's 1 over 5. U was 5x plus 2, all to the power of 8 over 8 plus c, and of course we can multiply the denominator so it doesn't look so bad, so we will have 5x plus 2 to the power of 8 over 5 times 8 is 40 plus c, and that's the end of our result. And there are so many more examples of problems with substitution. I would like to make more videos of those, but if you have a particular one that you're concerned with, then just put it in the comment and I will solve it for you as soon as possible. Thank you.